In this video, we're going to continue talking about the fundamental theorem of calculus. We are looking at example 4. From our previous 3 examples, we know when we integrate this one, we're going to get negative x squared plus 3x. We've already done that work. We're going to go from negative 1 to 3. We are supposed to shade this on the graph, so we're going from negative 1 all the way to 3. So these are the 2 triangles that we're working with. So let's see, I'm going to plug in. So I've got negative 3 squared plus 3 times 3 minus parentheses negative 1 squared plus 3 times negative 1. So 3 squared would be negative 9 plus 9 minus, and it looks like negative 1 minus 3, because negative 3 times 1 is negative 3. These guys are going to cancel, and then I get negative 4, which is going to be positive 4. Which makes sense. Look, the triangle in the positive triangle is bigger than the negative triangle. All right, finally, let's look at this one. Again, when we integrate it, it is going to be negative x squared plus 3x. So we're going to go from 0 to 5. So let's see, we're going from 0 this time to 5. And look, ooh, interesting, the triangle underneath the x-axis is bigger. So we're plugging in, so negative 5 squared plus 3 times 5 minus parentheses negative 0 squared plus 3 times 0. Negative 5 squared would be 25, negative 25 plus 15, and then this back piece is all just going to be 0. So we'd end up with negative 10, and the area underneath is bigger. All right, so we're going to summarize what we just did in those 5 examples. So based on the results of the 5 previous examples, what inferences can you make about the value of a definite integral and the amount of area bounded by the graph of the integrand in the x-axis? So first of all, we're going to say that the integral from a to b of f of x dx equals the area of the region bounded by f of x and the x-axis. We proved that in the very first example. Okay. And then we saw some different patterns. So we noticed that if we have the integral from a to b of f of x dx, if the region bounded by f of x and the x-axis is above, is what happened? X-axis above, not is above, x-axis above is larger than the region below. Oh, f of a, I missed greater than 0. So basically I get a positive area, a positive integral if the region on the top is bigger than the region on the bottom. If the integral from a to b of f of x dx is less than 0, the region bounded by f of x and the x-axis below is larger than the region above. And then finally, if it's equal to 0, because that was the other scenario that we have, f of x dx equals 0, then the regions above and below the x-axis are equal.